Hello guys, hope you're doing well. And as always, if you are new to my channel, I would humbly request you to subscribe to my channel so that you shall be able to watch all my latest engineering videos for your that will be helpful for all your future problems and basically assist you in your uh, engineering studies. Thank you. The problem at our hand is basically related to the concept of what is called as system of forces and couple moments. Okay, system of forces and couple moments, it is a system in which basically we have forces acting and basically the couple movements acting. Okay, it can also be individual forces, and the forces are acting in such a way that they're making some angles of direction cosines, are making some angles with different axes to create couple movements. So when we encounter this kind of a situation in which forces and couple movements are acting, the main equation that we basically uh, interact over here is basically, if you look at it, for example, in this scenario, we have an origin point O, and basically a force F1 is acting, force F2 is acting, and we create specific moment arms from O to reaching point F coordinates. We create a moment arm R1, and to reach to F2, we create a moment R2. And again, we know this R1 and F1 will create a specific moment, and R2 and F2 will also create a specific moment. And that is basically, if you look at it here, is m1 equals to r1 cross f1 and m2 equals to r2 cross f2. Okay, and then there is also a couple moment acting over here, which is basically going to be included in our system, and our resulting equations will be this fr equals to summation of all the forces, and for moments we have to sum up all the moments together. So these are the equations that we will be making use of it in our problem that we have just going to discuss with you guys. Okay, so if you look at it over here, is basically he says the slab over here, which is being shown, is to be hoisted using the three slings shown. Okay, so the one sling is here, the second sling is here, and the third sling is basically here. These are the three slings, and this slab is not a very lightweight thing. It is basically in tons, its weights in tons, which means 1000 kg, 1500 kg, so very heavy. We have to be very careful when lifting this system. So replace this system of forces acting on the slings by an equivalent force and couple movement at point O. The force F1 is vertical. So we have just discussed, when this kind of system of equivalent force and couple movement comes, what are the main equations that we shall be using. Okay, so just to let you know that we have discussed, this is our equivalent force and couple moment system that we have just discussed. Okay, over here. Okay, and in the end, what we are supposed to get for our system is basically an equivalent resultant force and equivalent couple moment which is acting about point O. Okay, so this is what we are going to get. So once the theoretical concept is being introduced to you, now we can basically see in the system of ours is that you look at it, there is one force which is F1, there is another force is F2, and the third force is F3. Okay, this force F1, if you look at it, it is basically acting at this unique point. And if you look at it, what will be the, first of all, very important, the coordinates of this point is that we have to move from the origin to some distance along X. Okay, so this distance is how much from here to here is basically, if we go parallel to X, is basically 2 meters. And to come to this point over here, we have to move parallel to the basically what is called as the y-axis, and this distance is basically 6 meter. Okay, so remember, this point is basically for F1 is 260, and for the force F3 it will be 000, because it is lying at the point of origin O. And this force, which is what called as F2 force, is acting at this point. So in order to reach this point, we have to move along the x-axis by a distance of 4 meters. So in order to have the coordinates for the force F2, it will be, remember, 4 on the x-axis, y0, z0. Once this is being decided, now we basically have to calculate the resultant force vectors to get our resultant Fr. Okay, so this force F1 is, if you see, is lying parallel to the z-axis, so we can just simply say this F1 equals to 6k kilonewton, because it is parallel to the z-axis. Now we go to F2. Okay, if you look for the F2 force, which is basically, this is our F2 is basically 5 kilonewton. Okay, and to understand this F force, we can basically go to here. Okay, so this F force will be making one component which is parallel to the z axis. Okay, and this component will be 5 sine 45, because it is lying, its sense of this vector will be parallel to the z axis, because this is the resultant sense of the vector, and this will component will be the z component. Okay, so this is very clear. And you can basically, if you go here, you can see that one of the components for the f2 is basically sine 45k, 5 sine 45k. Now you go again and you basically look for the other components. Okay, so if we are basically interested in calculating the component which is parallel to the x-axis. Okay, so again the sense is in this direction, so the x component will sense will be basically uh, in this direction. Okay, which is basically the negative x. Okay, so we can make this component as basically, again it will be basically what is called as cos 45. Okay, one component will be cos 45, and the other component, if you look at it, will be basically what is called as the sine of the 30. Okay, but this sense of this component will be towards the negative x. Okay, so if you look at it over here, it will be cos 45. Okay, and the sine 30, but the negative sign is here, which I have told you. What about the other component, the j component? The j component, if you look at it, it will be again the cos 45, this component, and the j component will be parallel to the y-axis. So it will be again cos 45, and the sense will be towards the positive y. So it will be cos 45 and cos 30. So you can see if that is this true or not. So if you look at it, for the j component, cos 45 cos 30j plus sine 45k, you simply multiply the cos 45 angle with the sine 30 to get the I component, then multiply cos 45 cos 30j with 5, you get the j component, and you multiply 5 with the sine 45k, you will get the k component. So this is f2. If you look again at f3, f3 is making some three angles with the three axes. Okay, the angle with the x-axis is 60, the angle with the y-axis is 60, and the angle with the z-axis is basically 45. So I can easily predict that these are basically the three angles are the direction cosines of this vector, Cartesian vector. Okay, so we can say f3 will be 4 cos 60i plus cos 60j plus cos 45k. Calculate the cosines to get the value of f3 as this. Now we know the resultant force Fr of this system will be F1 plus F2 plus F3, and we will be adding all the respective i's, j's, and k's that we have calculated. If in F1 we have calculated in basically F2, and we have calculated in F3, we'll be adding them, and them and so F1 plus F2 plus F3, when they are being added, the resultant force comes out to be equals to basically we are adding up all the I, J, and K's, minus 1.768I plus 2I, 3.062 plus 2J, and 6 plus 3.536 plus 2.82K. So this is our resultant force of this couple and force moment system. Okay, this is the resultant force, and when we add all the i's of this system, we get 0.232i plus 5.06j plus 2.4k. Okay, so this is our resultant force of this whole slab system, which will be acting, and these are the I, J's, and K's of this whole resultant system, in which we have a multi angles. We have basically direction cosines and an axial force, and which is parallel to the z-axis. Once this is being done, now we are interested in calculating the couple moments at point O. This is the point O. For the couple moments, we have to calculate, these are the forces. We have to take from this point what will be the position vector from this point to this point, and what for F1, and what will be the position vector from this point to this point. This will be R1 cross F1, the other one will be R2 cross F2. Okay, and we already know that these are the locations of F1, F2, and F3. Okay, and these are the position vectors we have already explained you. Okay, so we know resultant moment of this whole system will be the addition of R1 cross F1 plus R2 cross F2. There will be no resultant moment for F3, because it is lying at the origin. There is no moment up. So for R1 cross F1, we will take the determinant of ijk. What will be the position vector for R1? It is 2i plus 6j, so 260. And what will be the force value for F1? It will be, since it's parallel to z axis, so 006k. Plus what will R2 F2? It will be again ijk, and R2 will basically be equals to 400. It is 400. What will be the force for this vector that we have calculated it over here is basically minus 1.768i, 3.06j, and plus 3.54k. This is basically for the vector f2, and it is here minus 1.768i plus 3.0622 plus 3.536k. So we can calculate this determinant analytically, or you can do it by your calculator to get these results: 36i minus 12j and 0i minus 14.14j plus 2.248k. Now what you have to do, to, since the moment can also be will be also be like a vector addition, we will collect all the respective i's, we will collect all the respective j's, and collect all the respective k's to get our resultant moment as 36i minus 26.14j plus 12.25k kilonewton meter. Make sure you don't forget the units, they are very important. uh, Otherwise you won't able to differentiate between a force and a moment. Okay, so this is was a good problem. I hope you have understood this force moment problem. For it's a three-dimensional problem. So I thank you all, and I hope you all guys have a wonderful day. Bye.